Hello and welcome to our YouTube channel Chemistry with Tanvi. In previous lectures, we study up to the point preparation methods of halogen derivatives. In today's lecture, we start the new point from the same chapter, that is optical isomerism in halogen derivatives. For this, we know about the knowledge of isomers. What is mean by isomers first? Isomers are the compounds. They are having same molecular formula but different structural arrangement. Here, for this point, we know about knowledge for the stereoisomers. So, stereoisomers are isomers having the same bond connectivities, that is structural formula, are called stereoisomers. Same bond connectivity. Same bond connectivity. That means stereoisomers are the compound in which the bond connectivities are same, though they are appear in which manner different. So for this, the new concept is arrived, that is optical isomerism. So for this, we know about the what is mean by chiral atom and molecular chirality. Chiral atom. What is mean by chiral atom? Chiral atom means carbon atom in a molecule which contains or carries the four different groups or atoms attached to it. Such type of molecules are known as chiral atom. They are also called as asymmetric carbon atom. Another name of chiral carbon is asymmetric carbon atom. It is always represented by making star on carbon atom. This is the simple representation. So let us see the example of 2-chlorobutane. This is the molecule named as 2-chlorobutane. Why this is 2-chlorobutane? Count the carbon atom 1, 2, 3 and 4. So it is known as butane. At which position? The lowest position for different group attached, that is halogen, present at a second position. From we mark 1, 2 as 3, 4 from the left hand side. So it is known as the 2-chlorobutane. This is IUPAC name. So in that, carbon number 1, which groups are attached? 3 hydrogen and this remaining is group. So 3 hydrogen and this group is attached. So in carbon number 1 there is presence of same 3 hydrogen, so it is not chiral carbon. For carbon number 2, there is presence of 1 hydrogen, 1 chlorine, 1 CH3 and CH2CH3 group. So all 4 groups are different, that means it is a chiral carbon. So at carbon number 3 there is presence of hydrogen, CH3 and CHCl and CH3. So there is presence of 2 same hydrogen. So no, there is absence of chirality for this carbon number 3. And there is presence of carbon number 4, presence of 3 hydrogens and remaining this group. So 3 hydrogens are so same. Here it is a not chiral carbon. So in 2-chlorobutane, carbon number 2 is our chiral carbon, or it is also known as asymmetric carbon atom, making star on it. And then next is non-superimposable mirror images of this compound. If we adjust this carbon, we know that carbon is a tetrahedral molecule or tetrahedral structure because of its 4 valency. So all 4 different groups attach in a tetrahedral fashion like this. And if we taking the mirror plane of this first and I am writing second, this is a 2-chlorobutane molecule, both are. Then what happen? If we put this second image on a first, then what happen? There is not exact matches the group CH3 first and second, but to this hydrogen there is overlaps of chlorine of mirror image. Then the C2H5 and C2H5 are bond angle changes, so not superimposed. This is superimposed, this is not superimposed. Directly atoms are changed here, and to this chlorine, on which chlorine there is hydrogen of this mirror image, so here also atoms changes. That means this image, mirror image, is not superimposable with each other. What is mean by superimposable? Suppose this is a square molecule, then mirror image of this is a square. If we put the square on square, there is exactly matches with each other. Such type of images are called as superimposable. And if we place this molecule here, H is there, then what happen? If we place, this is first image, and if we place this mirror image of this compound to on it, then what happen? Position of hydrogens are changes. That means position of atoms, bond connectivity is same, but the arrangement or the mirror image shows the different places. Such type of mirror images are called as non-superimposable mirror images. And the non-superimposable mirror images are also known as the enantiomers. What I am saying? Enantiomers. Non-superimposable mirror images are known as enantiomers. Enantiomers are also two types, dextro and leo. Dextro and leo rotatory. What they are actually? Dextro means D are denoted as a plus sign clockwise, and L means symbol of L denoted by minus sign. That means towards the left hand side. We will see in some time, in a few minutes. Okay, up to this we know what is mean by chiral carbon, what is mean by the non-superimposable mirror images. They are called as enantiomers. Then the next is for chiral atom and its mirror image, both have the same structural formula and of course the same molecular formula. The special arrangement of the four different groups around the chiral atoms, however, it is a different. These four groups arranged in a different connectivities or manner. In other words, the chiral molecules and its mirror images are the stereoisomers of each other. So these are the stereoisomers. Why it is so? Because in a chiral molecule and its mirror images are the stereoisomers of each other, because they showing the different mirror images. Then the next is, this is also known as the relationship between the chiral molecule and its mirror image is similar to the relation between the left hand and right hand. So this concept is known as handiness or the chirality. Handiness or chirality. Because mirror images are considered as one is right hand side and another is left hand side. The stereoisomer in which the isomers have the different spatial arrangement of groups or atoms around a chiral atom is called as optical isomerism. Optical isomerism. So the optical isomerism differ from each other in terms of the measurable property called as optical activity. Optical activity. Here, what is there? Stereoisomer showing the different spatial arrangement of atoms or groups. around a chiral atoms. Chiral carbon atoms. Okay, and this optical isomerism is isomers are differ from each other by terms of measurable property. This property is known as optical activity. To understand this optical activity, we should know the knowledge about PPL, that is plane polarized light. Plane polarized light. What is mean by plane polarized light? A beam of light vibrating only in a one plane. Okay, a beam of light which vibrating only in one plane in a space is called as plane polarized light. This light, plane polarized light, is made from the ordinary light. If we take the cross section of ordinary light, it looks like this because light is scattered in all directions. If we place the Nichols prism, then what happen? This ordinary light gets converted into the plane polarized light. This is ordinary light. This is plane polarized light. Nichols prism is a special type of prism made from the pieces of calcite, a crystalline form of calcium carbonate. It is a crystalline form of calcium carbonate arranged in specific manner. It is also called as polarizer. दैट मीन्स जो सब्सटेंस ऑर्डिनरी लाइट को प्लेन पोलराइज लाइट में कन्वर्ट करता है उसे हम क्या बोलते हैं? पोलराइजर. Then next, that is the optical activity. Optical activity, what actually definition is the property of substance which rotates the plane polarization of incident plane polarized light is known as optical activity. जो सब्सटेंस ये ऑर्डिनरी लाइट को प्लेन पोलराइज लाइट में कन्वर्ट करके घुमा देता है उसे क्या कहते हैं हम? ऑप्टिकल एक्टिविटी. द कंपाउंड्स विच रोटेट्स द प्लेन पोलराइज लाइट आर कॉल्ड ऑप्टिकल एक्टिव सब्सटेंसेस और कंपाउंड्स. जो सब्सटेंसेस अगर ऑर्डिनरी लाइट प्लेन पोलराइज लाइट के सामने रख देते तो वो क्या करते हैं? वो लाइट घुमा देते हैं आइदर anti-clockwise or clockwise. Suppose if we put the sample containing the optical active compound in a path of plane polarized light, then what happen? This plane polarized light either rotate towards the clockwise direction or anti-clockwise direction. Anti-clockwise. Here Nichols prism another way, and this here the viewer's eye. Okay, if the substance rotates the plane of polarization light towards the clockwise direction, then the substance is known as dextrorotatory. It is denoted by symbol D or sign plus. And if the substance which rotates the plane of plane polarized light towards the anti-clockwise direction, then it is known as levorotatory, denoted by symbol L and sign minus. And these compounds are called as enantiomers. Why they are called as enantiomers? Because they are non-superimposable mirror images, one having plus sign, one having minus sign. Dextro and levorotatory. And if the equimolar mixture of enantiomer, that is the dextro and levorotatory, is called racemic mixture. If the equimolar mixture, same amount of molar mixture of enantiomers, which enantiomers? Dextro and levo, then it is called as a racemic mixture. Okay, racemic mixture denoted by dl or plus and minus sign in a bracket. Okay. Up to this, optical activity and the optical isomerism of halogen derivatives point is completed. Let us see again the definitions of each. First of all, what is mean by chiral carbon? Chiral carbon is a chiral carbon. That means carbon atom containing all 4 different groups or atoms attached to it. What is mean by chirality? A molecule or object is chiral and it cannot be superimposed on its mirror image. It's called as chirality. It is a representation for optical active compound or optically activity or for asymmetric carbon. Then next is enantiomers. Enantiomers, the word is main, that is the non-superimposable mirror images. Mirror images of molecules that are non-superimposable on each other, they exhibit the optical activity in opposite direction, that is either from dextro or leo rotatory, known as enantiomers. Next is specific rotations. A measure of magnitude and direction of optical active substances. It is defined as the observed rotation of a polarized light at a specified wavelength, concentration and path length. The next is optical rotation. The rotation of plane polarized light as it passes through the optical active substance, it is measured using the polarimeter. The next is polarimeter. It is an instrument used to measure the angle of rotation caused by the optical active substances. The next is dextrorotatory. A substance that rotates the plane polarized light clockwise when viewed along the direction of propagation. It is denoted by D or sign plus. The next, leo-rotatory, describes a substance that rotates the plane of plane polarized light anti-clockwise or counterclockwise, that is minus, when viewed along the direction of propagation. It is denoted by L or minus sign. Racemic mixture, a mixture containing equimolar amounts of 2 enantiomers. Racemic mixtures are optically inactive. Very important point this. They do not rotate the plane polarized light because their rotation cancels each other out. It is denoted by either DL or plus and minus. The next is optically active substances that exhibit the optical activity due to their molecular structure and the chirality. Okay. Then next is representation of configuration of a molecule. This is another simple point. There are 2 representations. First one is Fisher projection formula, also known as cross formula, and another one is wedge formula. In Fisher projection formula, what happens? There is simple representation of chiral carbon. Chiral carbon is also known as asymmetric carbon, or it is optical active also. Asymmetric, it is optically active. Okay, here this is representation of carbon atom and showing the 4 different groups as making horizontal and vertical line. To the horizontal line, iodine and bromine is there, so it is represented as wedge line. Horizontal groups are showing by the wedge line. This wedge line indicates the bonds above the plane from the carbon, and this chlorine and hydrogen present as vertical line. That means in Fisher projection they are shown in a dotted line. That means the bond below the plane. This is the simple convection. That means in Fisher projection the bonds above the plane showing by putting the wedge line from carbon to atoms other and elements or the atoms below the plane showing by putting the dotted line. So the next is wedge formula. This is our second representation. We know that carbon atom is a tetrahedral atom. That means in a tetrahedral 2 bonds are present in a plane, 1 bond present above the plane and one bond present below the plane. So below the plane atoms showing by putting the dotted line, above the plane atom showing by putting the wedge line, and in a plane just showing by the solid single line. So this is the same molecule in which carbon atom is there, which is chiral one because containing 4 different atoms. This iodine is shown by the dotted line, that means this iodine is present at below the plane. Hydrogen showing by the wedge line, that means it's showing the above the plane. And bromine and chlorine showing by simple just putting the solid single line, that means it is present in a same or in a plane. Okay, this is up to the today's lecture. Thank you for watching. If you enjoyed this video and found it helpful, please give it thumbs up and leave the comment and subscribe too. Don't forget the hit bell icon to stay updated to our latest videos. See you next time. Thank you. Bye bye.